In this presentation, I'll be explaining classification of wind turbine. What are the different types of wind turbine? What is the classification of wind turbine? Now continuing the classification of wind energy system, WECS. The windmills machines are classified based on, one is based on the orientation of the axis of rotor. That is axis of rotation. Based on that one, they are classified as horizontal axis wind turbine and vertical axis wind turbine. That is based on the orientation of the axis. Second classification is based on the type of the rotor we are using. In that one, the propeller type and multi-blade type, both are horizontal axis type. And the third one is Savonius type, which is a vertical axis type, and Darius type, that's also vertical axis type. Therefore, this is another base of classification of the wind turbine. Now let us see horizontal axis wind turbine, HAWT, horizontal axis wind turbine. And horizontal axis wind turbines have blades like airplane propeller, and they are commonly have a 3 blades. Horizontal axis wind turbine uses lift force to rotate the blades, but vertical axis can be either lift force, drag force. Let us see what is that lift force as well as drag forces, and to generate the rotation. Now coming to here, just to explain that one, see this is the airfoil, and in that one you can see that one here the wind is flowing like this one, and here the distance to be traveled is more. Upper side the distance traveled is more than the lower side. Therefore here the velocity will be different. Here velocity of the wind has to travel more, than velocity will become more, and here the velocity will be less. And due to the difference in velocity, or that causes difference in pressure, due to that one, here the pressure, the high pressure will be the lower side, and here upper side there will be low pressure, or there is a pressure difference will be the from the lower and upper side of aerofoil. And because of the pressure difference, there will be an upward force. That force we call it as lift force. Therefore, that is this one. Horizontal axis vertical turbine uses the lift force. That can see that one. Due to the lift force, the blade can rotate. Same thing shown here. This is the lift force that makes to the blade to rotate. And there's another force, what we call it as drag force. Drag force is always, that is lift force is defined as the component of the aerodynamic force that is perpendicular to the flow of direction, and drag force is the component of that is parallel to the airflow direction. That is this force we call it as drag force. Therefore, in vertical axis wind turbine, both forces are using. We'll see later, either lift force or a drag force is using. Therefore, this is pictorially shown that one. This is the lift force. That is because of the difference in pressure. Here pressure is more and here is less. Therefore, a force will be coming here. And this is the drag force, which is in the same direction of the wind flow. Therefore, that is shown here also. Another one is that efficiency comparison. That is efficiency. Horizontal axis vertical. Horizontal axis wind turbine is more efficient with a higher power output compared to the vertical axis wind turbine. Horizontal axis wind turbine, continuing that, as we have already seen in the last slide, this is a lift based wind turbine, in which because of the pressure difference, here the pressure is more and here is less. Because of that one, a force will be going upward direction. That is called the lift force. And here, due to that one, that will be rotating the shaft. Blade will be rotating. That causes shaft to rotate. So this is a lift force based wind turbine concept. And the same thing, the setup. This is a schematic diagram of a horizontal axis wind turbine, in which this is the blades as such that's rotating, and there's a hub that is connecting that one with the main shaft, and there's a gearbox to of course to change the speed as such, because here the speed is less, but at this generating side the speed is to be increased. Therefore, that is done by this gearbox mechanism. There's a gearbox is there. There's a braking arrangement is there. If the wind speed is more than what is the limits that there's a braking mechanism is also there, and that is coupled to the generator, and that will produce the voltage or AC power will be generated by this. This one, that is the generator, and of course this is a housing, and this is a blade as such, and this is the tower, and this is a tower. Therefore, this is a pictorial representation of a horizontal axis wind turbine. The axis is horizontal here. This is the tower, and this axis is horizontal. That is why it is called horizontal axis wind turbine. And in that one, the rotation is because of the lift force that is developed. Now, coming to the propeller type windmills. Propeller type windmills, these are most commonly used windmills, and that is also a horizontal axis wind turbine, also machine, horizontal axis, wind machine. And fixed propeller type turbines are generally used for large units at low heads, resulting in a large diameter and a slow rotational speed. And here, lift force based wind turbines blades are becoming more common in this case. Lift force is using, as we have seen in the last slide. For such a windmills as 2 or 3 blades for economical result. Though the 2 blades design is most efficient, yet it faces the difficulty of vibration during the orientation to the wind directions, called yoke control. Yoke control controls the blades into the wind direction. That control we call it as yoke control. We'll see later. Therefore, that is always yoke control is there in a horizontal axis wind turbine. There's a yoke control is there. These machines are rated 1 to 3 megawatt, and the diameter is approximately 2 to here 2.5 meter. That is, diameter will be 2 to 2.5 meter, the diameter. Therefore, this is a propeller type windmills. The second type of what's called multi-blade wind turbine. This is also horizontal axis horizontal axis wind turbine. And the multi-blade wind turbines are high solidity turbines used for pumping the water because of high starting torque characteristics. Because here, as the number of blades increases, the starting torque increases. And this is also a horizontal axis wind machine, multi-blade wind turbine like this one. For the multi-blade rotors are less efficient because of the interference of the blades in each other, but they are less noisy. Therefore, that is another point to be noted as multi-blade wind turbine. That is shown here is also multi-blade wind turbine. Continuing the multi-blade wind turbine, this is a multi-blade wind turbine. Modern water pumping windmills have large number of blades, and the large number of blades gives a high torque required for driving the centrifugal pump. Even at very low wind speed, it gives enough driving torque to drive the centrifugal pump. For as these windmills are supposed to be installed in near as a remote places, mostly as a single unit, reliability, sturdiness, and low cost are the prime criteria and not the efficiency. The blades are made up of flat steel plates working on the thrust of the wind and hinged to the metal ring to ensure structural strength, and the low speed rotation adds to the reliability. So that is a multi-blade wind turbine. Now continuing, multi-blade water pumping windmills are the, therefore they see, you can say a number of blades are there. And water pumping windmills have large number of blades, generally wooden or metallic slates driving the reciprocating pump. And windmills must have able to operate at very low wind speed, so that if the number of blades are more, that produce more torque as such. Large number of blades gives a high torque requiring for a driving centrifugal pump, even at very low winds. Hence, sometimes these are called fan mills also, like these multi-blade water pumping mills are called fan mills. And the blades are made up of flat steel plates working on the thrust of the wind. The orientation is generally achieved by the tail vane. Therefore, this is an example, or this is a pictorial representation of a multi-blade water pumping windmill. Now let us see vertical axis wind machine. As we have already explained, vertical axis wind machine, the axis of rotation is vertical. is a vertical axis wind machine. For a vertical axis wind turbine is a type of the wind turbine where the main rotor shaft is set transverse to the wind while the main components are located at the base of the turbine. Main components are located at the base of the turbine. This arrangement allows the generator and gearbox to be located close to the ground. This is the ground, and this generator and gearing mechanism is very close to the ground. Cost effect, facilitating the service and repair. There are two type of vertical axis machine or turbine, that is called Savonius type as well as Darius type. In Savonius type, that is a windmill, is a vertical axis wind turbine. In that one, the drag force is used. The drag force means the force in the same direction of the wind flow. That is called the drag force. That is used in Savonius type. We'll see in the coming slides. This is a Savonius type of windmills as such. You can see that when in this type of one, we are using drag force to rotate the blade. But the second one is that they do not have to turn into the wind stream as the wind direction changes, because their operation is independent of the wind direction. The second one type is called Darius type windmills. This is also vertical axis one. Both are vertical axis, but here the force that is using in vertical axis turbine, that is called the lift force, is using. The lift force, that is the because of the pressure difference on the upper and lower side of the blade, there will be a force that is developing. That is called the lift force. Is that therefore that is using in the case of a Darius type windmills. So for that we'll see later. This is a Darius type windmills. That's also vertical axis wind turbine. In that one, here the lift force is used to rotate the blade. For these are the two vertical axis wind machines. One we call it as Savonius type. This is this one. Second one we call it as Darius type windmill. We'll see later the next coming slides. First, let us see what is a Savonius type windmills. Savonius type windmills. This type of windmill has hollow circular cylinder sliced in half, and the halves are mounted on a vertical shaft with a gap in between. That is, a cylinder is made to half, and that is that is mounted in a vertical shaft, so that you can say that one is concave, another one is convex nature. And the torque is produced by the wind force exerted on the two surfaces, which gives the rotor a torque. A torque will be produced because of this wind force which is exerted. One is called concave side, other one is the convex side, and that is the same thing like this one. Here, because of the wind force on these two sides, that produces a torque, or that produces a rotation. For the torque is produced by the wind force exerted on the two surfaces, which gives the rotor torque. This is a pictorial representation of a Savonius type of windmill. Same thing, this one also. So this is the way in which the force torque is producing. We can see this one, that these are the blades, and this is again that's a vertical axis type, but here so one is curvature is concave, other one is a convex, and because of this difference in force that is falling on this one, a rotation that will be producing a torque, or that will be producing a rotation. That is the Savonius type of windmill. Continuing the Savonius type of windmill, here as we have seen, the basic equipment is a drum cut in two halves vertically. As I already told, a cylinder cut in two halves. This is the one half. This is the second half. That is mounted on a vertical axis. You can say one is concave, another one is the convex. And when the two parts are attached to the two opposite sides of a vertical shaft. Two opposite sides of a vertical shaft is attached. And as the wind blowing into the structure meets the two dissimilar surface, one is the convex, another one is the concave surface. Convex and concave surface are, that is, wind is falling on this one, and the forces exerted on these two surfaces are different, which gives the torque on the rotor. That is, the forces are different on the concave as well as convex surfaces. Because of the difference in forces, that produces a torque, a rotational forces, or that makes the blades to rotate with respect to the vertical shaft. This is a vertical shaft. These are the two concave and convex part of the this Savonius type windmill, concave as well as convex part. As again, this is a picture of a Savonius type windmill. Continuing the Savonius type windmills here, same as I already explained this one. One is concave, another one is convex. That to the air, the wind speed that will be producing the different forces will be coming on the concave and convex. That will be producing a rotation to the with respect to this vertical axis, vertical shaft. That's why it's called a vertical axis wind turbine. That is because of the nature of this concave and convex face. Surface of these blades. So by providing a certain amount of overlap between the two drums, the torque can be increased. This is because of the wind blowing into the concave surface turns around and gives a push to the inner surface and the other drum, partially cancelling the wind thrust on the convex side. And it has been found that an overlap of about 1/3 of the drum diameter gives an optimum result. That is regarding Savonius type of windmill construction side. Again, continuing a Savonius type of windmill. In that one, it is again, as I told you, it's a vertical axis wind turbine. It's a drag, and here, drag based wind turbine. It's a drag force is using here. Drag force is using, and drag based wind turbine is a Savonius type of rotor, drag based. In that one, wind is hitting here, and that the force is coming on the concave and convex is different, and because of that one, that produces a rotation along the vertical axis, that produces a rotation. Same thing here, shown here, a rotor drag force at the lower and drag force higher at here, and because of this drag force difference, that produces a torque that will be rotating this one, or this one will be rotated along with the with respect to the vertical axis. Therefore, rotation created by the difference in drag forces has the convex and concave surfaces on the rotor. That is the basic concept of Savonius type of rotor. Therefore, the drag force is in this one. The drag force is used to rotate the blades with respect to this vertical axis. That is the Savonius rotor. Second type of vertical axis wind turbine is called Darius type of windmills. Darius type of windmills. And this is a vertical axis lift force operated. In that one, lift force is used, not the drag force. Lift force operated device is invented by DJ Darius of USA. 2 or more flexible blades are attached to a vertical shaft. This is a vertical shaft. 2 or more shaft, this is attached to that one. And the blades move towards taking approximately the shape of a paraboloid and are of symmetrically aerofoil section. And for this machine, the torque is 0 when the rotor is stationary. Hence, the starting torque is provided by an electrical machine which initially runs as a motor and then as a generator. That's one. Of course, we can say the disadvantage of this type of Darius type of windmill, because starting torque is 0. Then we have to provide a separate mechanism to for starting. The starting torque is provided by electrical machines, which initially run as a motor and then as a generator. Therefore, this is a picture of a Darius type windmill. It's the same thing. We'll see in the coming slides. This is the continuing Darius type windmills. This is a pictorial representation here. Of course, this is the blades. You can say that one. Rotor blades are there, and the wind is the drag. Here the lift force is using. Here the lift force is using as such. Airflow comes here. Lift force is using, and because of the aerofoil nature and because of the difference in pressure, that will be rotating. And here you can say that one. There is again say vertical axis type. It's rotating with respect to this vertical axis, and bottom side there is a gearbox. This mechanism is there, and there's after that one speed is increasing. It's basically here speed is less, that is increased by the gearbox arrangement, so that the rotor speed or the speed of the rotor of the generator increases, or that is made to the required value, and the generator generate the electrical energy that is available at the output. These are the different parts of that one, rotor blades, the lower hub and upper hub, and the gay wire, and these are the blades, and this is the gearbox arrangement, and this is the generator. So these are the basic parts of a Darius type windmill, that is a vertical axis windmill, and the lift force is using to rotate this rotor. Now let us see the advantage of vertical axis wind machine. The rotor is not subjected to continuously cyclic gravity loads since the blades do not turn N over N. Since these machines would react to wind from any direction, they do not need yawing equipment to turn the rotor into the wind. There's no, yaw control is required here in the vertical axis wind machine. As heavy components like gearbox generators can be located at the ground level, this machine may need less structural support. Gearbox and generators are at the lower level that needs less structural support. The installation and maintenance are easy in this type of configuration, vertical axis wind turbines machine. Disadvantages of vertical axis wind turbines. Wind speeds are very low, close to the ground level. So although that tower can be served, wind speed will be very low on the lower part of the rotor. The lower part of the rotor, the wind speed near to the ground, wind speed will be low. The overall efficiency of the vertical axis machine is less compared to the horizontal axis vertical machine. The overall efficiency is less. The machine is not self-starting because as we have seen, various type of machine needs a separate mechanism to start, needs a push before it starts. This is only minor inconvenience for the grid. So that is a disadvantage of vertical axis wind turbine. Now let us compare horizontal axis wind machine as well as vertical axis wind machine. And in that one, the first is the power captured for the same height of the tower. The power capture that will be more in the case of horizontal axis wind machine. For the same height of the tower, the amount of power that can be captured is more in the case of horizontal axis wind turbine compared to vertical axis wind turbine. Second, effect of fatigue. Effect of fatigue means arising from the numerous resonance in the structure, mechanical resonance that happens. No such problem in the case of horizontal axis, but in this case suffers from the fatigue effect because of the rising from the numerous resonance in the structure that happens. The third one is appearance of the unwanted power periodicity that is there in the case of a vertical axis machine, that is not there in the case of horizontal axis. Noise problem that will be more in the case of vertical axis wind machine. And complexity of the yaw mechanism, because yaw mechanism that is less in this case, but here the vertical axis machine do not need a yaw system since their vertical axis can force the wind from any direction. Therefore here complexity of yaw mechanism exists in this case, but no such problem arises in this case. Vertical axis, there is no yaw control. There's no yaw control. That is, a vertical axis turbine do not need a yaw system since their vertical rotors can face the wind from any direction, unlike horizontal axis wind turbine. Therefore, there's no such yaw control in the case of a vertical axis wind turbine, but that exists in the case of horizontal axis wind machine. And complexity of the design, that is more in the case of horizontal axis wind machine compared to vertical axis wind machine. So these are the comparison of horizontal axis wind machine as well as vertical axis wind machine.